right, today we're looking at section 3-7, solving absolute value inequalities. Remember to take notes. You can pause the video at any time to take notes and complete the check it out questions at the end of each of the examples. Our learning target today is I can write and solve absolute value inequalities. So we have this inequality, absolute value of x is less than 5. What are the solutions for this inequality? Remember, absolute values are distance from 0 on the number line. Okay, so to solve this inequality, absolute value term is by itself, so we can break into inequalities, giving us the absolute value, or x is less than 5, and x is greater than negative 5. To graph this, our two endpoints, negative 5 and 5, are not part of our solution, so we have open circles there, and we'll shade everything in between. So looking at this, if we have the absolute value of x less than 3, it's a conjunction. So it's between the two endpoints, like we did with the absolute value is less than 5. With less than or less than or equal to symbols, think of less than with the and in there. And that's going to be between, it's conjunction. The only difference between our two symbols is our open dot and our closed dot. They're part of the solution or not. What do you think the solutions are for this inequality? Absolute value of x is greater than 5. For this inequality, again, our variable's already been isolated. So we can break it into two inequalities. X is greater than 5, or x is less than negative 5. Because when we graph this, our two endpoints are not part of the solutions. We have open circles. X is greater than 5 is going to go to the right. X less than negative 5 is going to the left. This type of solution is called a disjunction. And you think with greater with the or in there for the or. And again, just like with the less than, our two symbols only differ with the closed dot and the open dot. So remember, when solving absolute value inequalities, you want to always isolate the absolute value first. Not the variable, but the actual bars. You want to remove the bars. Get that by itself. Based upon the inequality symbol, rewrite without the absolute value symbols. So for less than or less than or equal to, make it into an and statement. And greater than or equal to is an or statement. And we just solve for the variable. So we have two examples we're going to look at. The first one, absolute value of x minus 3 is less than negative 1. Right now our absolute value term is not isolated. We need to do that first. Okay, so again, in solving this inequality, we need to isolate our variable. We need to add 3 to both sides, resulting in absolute value of x less than 2. Now it's by itself. We can remove the absolute value bars for the symbols. Get x less than 2. X is greater than negative 2. Put your two endpoints down, and they're open circles because they're not equal to, and this can be shaded everywhere in between. Look at our second example. We have absolute value of x minus 1 is less than or equal to 2. So now our absolute value term is all by itself, so we can remove the bars. So we can remove the absolute value symbols. We get x minus 1 is less than or equal to 2, and x minus 1 is greater than or equal to negative 2. Add 1 to both sides of the inequalities, resulting in x is less than or equal to 3, and x is greater than or equal to negative 1. Since it can't equal, our two endpoints are closed dots, and we shade in between. So again, with less than or equal to, this is a conjunction, and it's all points in between your two endpoints. Now it's your turn to try these two check it outs. So now let's look at when it's greater than or greater or equal to. Our first example is absolute value of x plus 14 is greater than or equal to 19. Solving this inequality, we had to subtract 14 from both sides of the inequality to isolate our absolute value term. Leaving us with x, absolute value of x is greater than or equal to 5. Breaking it into our two inequalities, we get x is greater than or equal to 5, or x is less than or equal to negative 5. And when we graph them, you see there is no overlapping piece here. This is a disjunction. Our two endpoints 5, everything to the right, and our other endpoint negative 5 has to be less than, so everything to the left. Our next example, 3 plus the absolute value of x plus 2 is greater than 5. Okay, so in solving this one, we had to subtract 3 from both sides to get our absolute value term by itself, leaving us with absolute value of x plus 2 is greater than 2. Our two inequalities then become x plus 2 is greater than 2, and x plus 2 is less than a negative 2. Subtract negative 2 from both sides of the inequalities. So our first inequality becomes x is greater than 0, or x is less than negative 4. So looking at our two endpoints, they're not part of the solution, so it's 0, it's an open circle, has to be greater than, going to the right. And our other endpoints in negative 4, not part of our solution, so shading everything to the left. And now it's your turn. Run through these two check-it-out examples and bring any questions to class. So now we have a story problem. A pediatrician recommends that a baby's bath be 95 degrees Fahrenheit. It's acceptable for the temperature to vary from this amount by as much as 3 degrees. Write and solve an absolute value inequality to find the range, and then graph the solutions. So with any story problem, you always need to define a variable. We're going to let R equal the recommended temperature, or the acceptable temperature. So we know that we're starting at 95, and it's got 3 degrees one way or the other. So our absolute value term becomes absolute value of R minus 95 has to be less than or equal to 3. It's less than, we know it's going to be an and, so removing the absolute value symbols, R minus 95 is less than or equal to 3, and R minus 95 is greater than or equal to negative 3. Adding 95 to both sides, we get R is less than or equal to 98, and R is greater than 92. Graphing this, we have our endpoint at 98 is part of our solution, so it's a closed dot. And our endpoint at 92 is also part of our solution, so it's a closed dot. And we shade everything in between. Now it's your turn to run through this check-it-out example. So just like with equations and our inequalities that we've been solving, absolute value inequalities can have solutions that are going to be given a true statement, so all real numbers are our solutions. It can also have a false statement where there is no solution. Let's look at a couple examples. So we want to solve the inequality. X plus 4 minus 5 is greater than negative 8. So we end up with adding 5 to both sides. We get absolute value of x plus 4 is greater than negative 3. And that is true because it's a true statement, because absolute values must be non-negative, so it's going to be all real numbers. Our next example, we have absolute value of x minus 2 plus 9 is less than 7. So we subtract 9 from both sides, leaving us with the absolute value of x minus 2 is less than negative 2. And this is a false statement. Just like in the last one, they must be non-negative numbers. So there is no solution. So here are your two check-it-out questions. Answer those two questions. So summarize, absolute value is a distance from 0 on a number line. And with everything you've been doing, go back and check your answers. Make sure your shading is correct and it makes sense. Get the absolute value expression by itself, isolate that. When you have a less than or equal to inequality, you're going to break that into two inequalities, and it's going to be and. And if you have a greater or equal to absolute value, it's an or statement. So you break them again into two inequalities, and you solve as you would an absolute value equation or a regular equation. Bring any questions you have to class, and thank you.